section 7.1, we kind of just defined recursive, like a recursive sequence. So just going back to what a recursive sequence is basically you're given a certain amount of information, and then you're able to come up with like the next term by using the previous term. Okay, I'm going to show you how that's set up. So a recursive formula is a sequence with when the nth term is based on the previous terms. So let's just hands-on do example 1. Write the first 5 terms of the sequence determined by this recursion formula. So the first term is 11. So what we're actually looking for is we're looking to just list the terms. So that's it. So it's not as easy as just subbing in 1, 2, 3, 4, and 5, okay? Because what this does is it builds on one another. So if we know T1, so that's good. Now let's find T2, okay? So if we sub in 2 for this n, T2 minus 1 minus 4, what this actually gives us is it's saying our second term, what we need to do is we need to sub in T1, which we knew was 11. And then what we're going to do is we're going to subtract 4 from it. So 11 minus 4, I think that's 7. Beautiful. Okay, and then we plug in the 7 here. Okay, so when we plug in T3, what we're going to get is T3 minus 1. So T3 is going to be actually based on T2, the result that we got from T2. So we're going to do the 7 minus 4, and we're going to come up with 3. And if you can see this already, this is an arithmetic sequence because it's going down by 4 every single time. It's taking the previous term and then it's subtracting 4. I'm going to do it just the long way one more time. So T4, and then we sub in like the n still is 4, so 4 minus 1. This term is going to be based on T3. So it's going to be 3 minus 4, I get negative 1. And we can see it's going negative 4 each time again. So let's just fill this in as negative 5. Now, example 2. Write the first 5 terms of this sequence, okay, determined by this recursive formula. So all of these are actually going to like list a formula. All of them will give you at least one term. Sometimes the recursion formulas are going to be based on 2 terms. So like you would have to add or multiply 2 of the previous terms. And then in that case, it'll give you 2 terms plus the formula. Okay, so let's go. T1 is 2. We already know that. T2 is going to be minus 3, and then T2 minus 1. So it's going to be negative 3 times the first term. Okay, so we know the first term is 2. So this one's just negative 6. Okay, now T3 equals, let's go negative 3 T3 minus 1, which is just negative 3 times the second term. Sorry, this is 2, which is negative 3 times negative 6. I get negative 18. Or sorry, positive 18. So if you just think about it, every single time we're going to be multiplying by negative 3. Okay, so after this, you can like start to pattern if you can see that. If not, go ahead and use the recursion formula. Okay. Use a recursion formula like on your test and everything for at least like 1 or 2 of these, and then if you can see a pattern, then that's totally fine too. Okay, so that's what we get for the first 5 terms, and now it wants us to write an explicit formula. Okay, so we have a recursive formula. Let's just write like the general term. So we know that this equation is geometric, so it's going to be in this form. Okay, so Tn equals A is the first term. Let's write it with a 2. The ratio is negative 3, and then n minus 1, and that's it. So we can take our pattern and we can write a geometric sequence, and then in the previous one we could have written like the general term for an arithmetic sequence with that as well, using the recursive formula.